Now, despite the fact that antibiotics have saved the lives of countless people across the world, its overuse has led to evolutions in bacterial DNA that allow them to resist it. And the only thing that we can do right now is to create new methods in which to combat the infections and other bacterial-related diseases. Now, first of all, as Anna mentioned before, penicillin was a huge discovery as it allowed the treatment of many bacterial-related diseases. Even now, we can still use it to treat things like strep throat and syphilis. However, back when it was first discovered, it could also treat a wide variety of infections, such as pneumonia. Why did they stop? Well, after World War II, many companies decided to start mass producing the penicillin in order to meet the worldwide demand, because that's how capitalism works. There's a supply, and then there's the demand. So this allowed the penicillin to reach a very large market of people across the world. And since it was used to treat a wide variety of the infections, it was inevitable that some of the infections became resistant to the penicillin. How does this work? Well, this all relates to microbiology. When a bacteria is faced with poor conditions, it can undergo what John Morris of the Institute of Creation Research calls a mutation mode. Now, this mutation mode involves stopping the mechanisms that check DNA replication. What does that mean? Well, for any organism to reproduce, their DNA must be replicated so the siblings, or the offspring, they have a copy of it. In order for the offspring to have a copy of it, the DNA must be correct. And while we do make mistakes while replicating DNA, we usually have other mechanisms that can check it. This is applied to both humans and bacteria. However, in this mutation mode, bacteria decide not to double check their DNA to make sure it's correct. And this leads to the foundation of multiple mutations. Now, if the bacterium is very lucky, it will stumble across a mutation that allows it to survive. Of course, having only one bacterium survive is not going to help the entire species of that bacterium. So what they do is they transfer the DNA in a process called lateral gene transfer. Now, bacteria can make a channel between two bacteria called a sex pilus. And what the sex pilus does is it allows the transfer of DNA between one bacterium to the next. Having the sex pilus allows the bacteria with the beneficial genes to transfer them to the other bacterium who doesn't have it, thus creating a herd-wide immunity. Soon, through replication and lateral gene transfer, all the bacterium in the colony will have it, and making the antibiotic you just used useless. Now, of course, it's easy for scientists to just make a second antibiotic. Of course, the problem with that is what I just described above. The bacterium is just going to get lucky again and find this different gene that allows it to resist the second antibiotic. And now we have a bacteria that is resistant to two different antibiotics. So what can we do about this? Well, we could just allow our immune system to naturally track down the bacteria and kill it. Of course, if the bacteria infection is lethal, we can't exactly do that unless you have a death wish. And according to Charles Davis of the Medical Net, this would actually make the bacterium even more dangerous because the recovery time would be increased for the patient due to the use of their natural immune systems, leading to more time for the bacteria to infect everyone else the person comes in contact with. The second method would be to just improve our hygiene. This would involve washing our hands and disinfecting commonly touched surfaces such as doorknobs, cell phones, and other things like that. Of course, other good methods would be to avoid dangerous foods that you suspect of having bacterial infections. For example, when I was in China this summer, I ate some raw seafood and ended up with an intestinal infection that left me in the hospital for a day. So in the end, the best thing we can do to combat the evolution of bacteria is to evolve ourselves. That way, we can eventually win the arms race against them.